Hi, this is Group 5's research paper presentation.
First, we'll look at the connection between chocolate and type 2 diabetes. So, starting off with the introduction, in the year 2019, 463 million people were diagnosed with type 2 diabetes, and by 2045, it's expected to rise to almost 700 million. Now, insulin resistance and decreased insulin secretion are hallmarks of type 2 diabetes, which frequently lead to consequences such as renal failure, eyesight loss, and cardiovascular disease. Different dietary variables, in particular, are crucial for management and prevention of this specific disease. Chocolate is actually one of the best dietary sources of flavonoids, which are naturally occurring substances that are anti inflammatory and antioxidant qualities that have been associated with a decreased risk of type 2 diabetes. However, different earlier research has yielded contradictory findings, in part because it frequently looked at overall chocolate consumption without making a distinction between different subtypes. Now, the differences in cocoa, sugar, and milk content between dark milk and white chocolate have had multiple impacts on health outcomes. While milk chocolate had no protective impact and was linked to weight gain, this study found that eating at least 5 servings of dark chocolate per week was associated with a considerably decreased risk of type 2 diabetes. These results imply that chocolate type has a significant impact on its correlation with body weight and the risk of type 2 diabetes.
Methods: population study. The study collected data from 3 large groups: Nurses Health Study, Nurses Health Study 2, and Health Professionals Follow-up Study. The study comprised of 289,569 participants, primarily nurses or health professionals. Individuals were assessed between 1986 and 1991 with a food frequency questionnaire. Participants were excluded if they had pre-existing diabetes, cardiovascular disease, cancer, or missing dietary information. Assessment of diet. Dietary intake was measured every 4 years using the food frequency questionnaire. Participants reported how often they consumed specific foods, including chocolate, over the previous year. Chocolate intake was assessed between 1980 to 1991. Information on consumption of dark or milk chocolate was available in 2006 to 2007. Nutrient intakes, including flavon-3-OL and total flavonoids, were calculated using the U.S. Department of Agriculture Food Consumption Database. These measures helped to link chocolate consumption to nutrient availability for energy intake. Assessment of confounding variables. In all 3 groups, information on participants' demographic, lifestyle, medical conditions, and other personal factors were collected every 2 years through questionnaires. Height and weight were measured to calculate body mass index, and the alternate healthy eating index was used to assess overall diet quality. Collecting these data allowed researchers to account for factors that might influence chocolate consumption and diabetes risk. Assessment of type 2 diabetes. Type 2 diabetes was self-reported in questionnaires and then was confirmed by a supplementary questionnaire that was reviewed by doctors. Depending on the year, individuals with confirmed type 2 diabetes was diagnosed using the criteria consistent with guidelines from the National Diabetes Data Group, American Diabetes Association, and HbA1c. Statistical analysis. To examine the relationship between chocolate consumption and the risk of type 2 diabetes, the researchers used the Cox proportional hazard models, which is a statistical comparison model. These models allowed to estimate hazard ratios, which in this study represented the relative risk of developing type 2 diabetes among individuals with different levels of chocolate intake. The first model analyzed each group separately to identify population differences, and then results were pooled to provide overall estimates. The second model was used to evaluate how changes in chocolate consumption related to 4-year changes in body weight. The third was to evaluate the sensitivity analysis, which were performed to test whether results were consistent with differing measures of chocolate intake, adjusting for age, lifestyle, and BMI. And the last was used to examine the dose-response relationship between dark milk chocolate, using a model to assess whether risk changed gradually across levels of chocolate intake.
All right, so the type 2 diabetes risk results showed a dose-response relationship, which means that as participants ate more chocolate, they tended to have lower chances of developing type 2 diabetes. This association was strongest in dark chocolate and weakest in milk chocolate, as you can see on the hazard ratio graph. Hazard ratio compares how many people in each group developed type 2 diabetes between these chocolate eating subtype groups and a control group which ate little to no chocolate. So a hazard ratio of 1 means that it's the same diabetes rate between groups, meaning that if the hazard ratio of milk chocolate, say, were 1, then eating milk chocolate would have no effect compared to eating no chocolate. If the HR is less than 1, it means there's a lower rate of type 2 diabetes in the chocolate group in question. So, for example, the HR in the dark chocolate group is right around 0.8, which is less than 1, meaning there's a lower rate of type 2 diabetes in the dark chocolate group. And an HR higher than 1 means there's a higher rate of diabetes, which we don't see here. More risk results. Dark chocolate consumption of at least 5 servings a week is linked to a 21% lower risk of developing type 2 diabetes. For overall chocolate, we see a smaller risk reduction of 10%. So dark chocolate is better than a combination of dark and milk chocolate. And then for only milk chocolate, any change in risk is insignificant, which means it's not big enough to say that milk chocolate affects risk at all. We can see the differences in the hazard ratio graphs that we just looked at. Weight change. Eating an increasing amount of milk chocolate was associated or linked with weight gain over time. I know this figure is kind of dense, but that beta star value is representative of the increase in weight over time in proportion to the increase in chocolate consumption. Dark chocolate was not associated with any significant change. And in the milk chocolate group, individuals with obesity or a body mass index greater than 30 tended to gain more weight on average than individuals who were not obese. So what does that mean? It basically means that dark chocolate might be a better dessert choice than milk chocolate for anyone who's worried about type 2 diabetes risk. Dark chocolate has more cocoa, which is the ingredient that comes from the cacao pod, and less sugar in it than milk chocolate does. So because it has more cocoa, dark chocolate contains more flavonols, which are flavonoids or plant pigments that are found in tea, cocoa, berries, and some other plant-based foods. They are not essential nutrients, but they have been suggested to have antioxidant and anti-inflammatory properties, which would affect diabetes risk because cell damage is a part of it, and inflammation is part of the negative impacts of diabetes. It's important to note that chocolate consumption and diabetes development do not have a causal relationship. There is no cause and effect that has been established here. There's a correlation or a link that's been established, but that doesn't mean that a certain type of chocolate consumption will cause you to develop or not develop diabetes. There are also confounding factors, including broader lifestyle choices like other diet choices, such as eating more fruit and vegetables and exercise.
After looking at what the researchers had found in their results, they had mainly concluded that the intake of dark chocolate over milk chocolate would be associated with lower risk of type 2 diabetes. This helps to impact like how we choose what food we might eat more of, how this could further the impacts on our own personal diet, and also what other factors could potentially lead to type 2 diabetes in the future. They also had concluded that moderate chocolate consumption could help maintain a balanced diet, and that they also found that increased consumption of milk chocolate was associated with increased weight gain. This impacts us in like our daily lives because it kind of makes us more hyper aware of what we're putting into our bodies and potential factors that could impact us in the future that we weren't quite sure of originally. Based off of what our group had concluded after reading the researchers' studies and results, we had agreed with their findings and their interpretation, as the study's design did include a large sample size, which made it easier and less to avoid more biases and to have a more whole type of data where less confounding variables might take place. And they also presented the results that showed a difference in the chocolate's impact on type 2 diabetes, which they showed in the results slide, showing the different factors that could contribute to the intake in type 2 diabetes. My group also concluded that after looking at like the controls and the results for future, we think that having more randomized control trials that are connected to cacao flavoring and insulin sensitivity could help further the research. Insulin's a big part of type 2 diabetes and diabetes in general, and being able to pinpoint more factors that could impact that would be a great way to expand in the future. And we also thought they could explore more with the use of different types of chocolate, and the chocolate varies in added sugar because added sugar could be another potential confounding variable to why chocolate has such a big impact on type 2 diabetes. And that is it for our presentation. We hope you learned a lot more about chocolate, type 2 diabetes, and how they could potentially correlate to each other. Thank you so much.